All right, ladies and gentlemen, well, it's a new day in Algebra 2. We have moved on to our new resource, the Algebra 2 workbook that is entitled Explorations in Core Math for the Common Core. Make sure you have your book open to page 41. I'm going to be going through some of the guided notes from the book, and then we'll do some practice in class from the book as well. First thing, the top part of this slide, you will not see this in the workbook, but as I get down to the second part of the slide, that's where we will pick up on page 41. The reason that the top part isn't on there is because I feel like it's important we do a quick little refresher of what a quadratic is and what it looks like, okay? So a quadratic is called a quadratic really because of one thing, and it's because of this exponent right here, okay? That exponent essentially makes this a quadratic because it is an exponent of 2. That thing's called the degree of the function, okay? That's called the degree. And as long as the degree is a 2, then we're going to have a quadratic. It's either going to be a smiley face up or a frown face down. So let's go ahead and let's take these x values from this table that I have, and let's just plug them in and see what comes out. So if I take negative 2, and I put it right there in place of the x, negative 2 squared is a positive 4. Negative 1 squared is 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. Now each of these that I just came up with is an ordered pair on the graph of the function, which is negative 2, 4. So if I go ahead and I plot these ordered pairs, we will find out what this x squared function looks like. And this is called the parent function. Okay, this is called the parent function because there's nothing in front, nothing behind, nothing below. It's just stripped down to the basics. Y equals x squared. So if I plot the point negative 2, 4, that's to the left 2 and up 4, and then I plot negative 1, 1, sometimes the points come out a little bit better if I just, come on. Maybe not. Okay, being stubborn today, so we won't do that. Okay, negative 1, 1, 0, 0, 1, 1, 2, 4. If I went a step further and I did negative 3 squared is 9, that would give me the point negative 3, 9. So to the left 3 and up 9 puts me up here. And I also know that 3, 9 would be the same on this side. So these parabolas for quadratics are always symmetrical. They're the same on one side as they are on the other. That first one wasn't very good. Let me try that again. That's better. Okay, so this is a quadratic, all right? If there's a negative in front of the x squared, that's what's going to make this thing a frown face, all right? So it's either smiley face or frown face. In this case, I'm smiling. So, now that we've had a little introduction into quadratics, let's talk about what vertex form is. Now, in the example I just put at the top, all we had was this basic y equals x squared, all right? There was nothing in front of it. If I, let's see here, let's say I erase this squared. If I kind of move that squared out a little bit, there's nothing inside this parentheses, and there's nothing after it. Okay, so this was just the basic y equals x squared function. Nothing inside, nothing in front, nothing after. Sometimes we will have things that are outside or in front or after, and that's what's considered, those are our shifts, left, right, up, down, or our stretches or compressions. Okay? I'm going to pause this for a second and type in the appropriate things in the box. Okay, so when we look at vertex form, there's really an understood a in front of our x. There's a minus h inside here, and then there's a plus k. Now, of course, if the a is a 1, like it is in this case, okay, if a is 1, and then h if there's nothing with the x, essentially that h is just 0, okay? So it'd be like x plus 0 in here, and then an x plus 0 out here. Because there's a 1 and then the plus zeros, there's no reason to write those, so that's where the y equals x squared comes from, okay? In other cases, there are going to be numbers inside, outside, and in front. We talked about that in the previous unit. So the A indicates our stretch or our shrink or compression. And if that number is negative, then that flips over the x-axis. That's a flip over the x. That's where the smiley face becomes a frowny face. The number on the inside, as we talked about last unit, that's the one that's a little tricky. Because if that h is negative, then it's going to go to the right. Well, let me take that back. That's not necessarily the case. We'll talk about that coming up here. Because this is a negative, this is a minus inside of the sort of the standard form, the vertex form, the h itself would actually be positive. Okay, so if the h itself is positive, then it does go to the right. If the h is negative, then it does go to the left. But the difference comes in when you have a minus and negative, it'll look like a plus to you, and it'll move to the left when it looks like a plus, but the h itself is negative. We'll talk about that on a couple of the examples coming up. And then the k, the positive shifts it up, and the minus shifts it down. All right. On your sheet there on page 41, they give you an example of a function, and they mention a couple other things. First thing are zeros of the function. So that's right here. We talked about that last unit. Your zeros of the function are where the graph crosses the x-axis. Okay? Really what that is those are two values that when you put them into the x's, the output is 0. That's why they're called zeros of the function. They're not just called x-intercepts. They're called zeros of the function because when you put those values in this case, x, it looks like x is -1, and where x is positive 1 and positive 5, looks to me like those are the zeros. When I put 1 into this function, my output is 0. When I put 5 into this function, my output is also 0. A couple other things here of note are the vertex. Now the vertex is right there. You'll note that this vertex goes to the right 3 and then down 4. That's the vertex of this function. 3, -4. So when you think about shifts, that's a shift to the right 3 and then down 4. So that 3, -4 corresponds right here with my h and my k, because I went to the right 3 and then I went down 4. So when it comes to writing the equation for this graph, that vertex is a big thing for us. You'll see that here soon. And then lastly, we have this line, the axis of symmetry. That's the dotted line that the right side of the function mirrors the left side of the function. They're exactly the same if you flip them over that line of symmetry. In this case, you see that that line is at 3, okay? For that dotted line, every single x value is 3. The x's are always 3. The y values are different. The y goes up 1, up 2, up 3, down 1, down 2, down 3, but the x values are always 3. So that axis of symmetry is the line x equals 3. These are some basics of quadratics and vertex form.